Now, growth and decay functions are just values that grow or decay exponentially. We're looking at something like this. So if you've got data, it might be years across the horizontal axis and maybe population up the vertical axis, and so over time it's going to grow like that. So the growth each year is more than the growth of the previous year. So that's exponential. Some types of questions you're going to get will be, you might be given a graph or maybe a set of data, and you might be asked to say, well, is it actually exponential? So what you would do there is you would just choose easily identifiable points along your graph. That one, and then at time 1, then at time 2, and then at time 3, and then at time 4, and time 5, for example. And what you do is you would divide that value by that value and get an answer. Then divide the third by the second, get an answer. Divide the fourth by the third and get an answer. And keep repeating the pattern. Divide the fifth by the fourth, divide the sixth by the fifth. If you get the same answer every time, you know you have exponential growth. And that number that you get each time is called your growth factor. It's the amount that go from one generation or one time period to the next, the amount that it's going to grow by. So if you ever get that sort of question, you take successive values and divide them and keep repeating that process and you get the same answer all the time, you have exponential growth. Similarly, if you have something that's decaying, if you take successive values and divide them together, you'll also get a constant number. In this situation, you'll get an answer that's going to be greater than 1, that's growth. Here, you'll get an answer that's going to be less than 1, that's decay. Oh, by the way, less than 1, but it's also going to be greater than 0. So anywhere between 0 and 1 means you're decaying, greater than 1 means you're growing. Let's have a look at this problem. So some particular item starts off at $6.50, and every year its price increases by 3%. What should it be worth in 8 years' time? Now, we have to just generate a basic formula. Now, before we get the basic formula, we need to state what variables we're using. So there's going to be the cost of the item, so we might as well call that C. So you need to state the variables you're going to use. So let C be the cost, and make sure you state the units. Now, it's also talking about time period. Will that little t be the time period? So little t will be the time in years. Right, priority 1, state your values that you're using, plus any units that are attached to them. And then you have a general formula. So we have C and T are my variables. So the general pattern always follows this for exponentials. It's going to be, so C, the cost at any particular time is going to be given by A0 times by growth factor to the power of T. What does that mean? Well, C is cost at any time. That's what we're trying to work out. A0, A is the amount that you have at time 0. So do we know the amount at time 0? Yes. The amount at time 0 is $6.50. So all exponential formulas will always start, the very first value here is what you start at time 0 when nothing has started to happen yet. Now, growth factor. How quickly is it growing? Now the growth factor is, at each particular time period, you have 100% of the value. You then add on 3% of the value. As it says here, that's by 3%, which gives us 103%. So to go from one time period to the next, you're increasing by 103%. 100% just means it stays the same, and you put another 3 on top. So converting that to a decimal, that gives me a growth factor of 1.03. The 1 indicates 100% that I start with. 0.03 is the 3% extra that gets placed on top. So the growth factor will be 1.03 to T. There is the rule that generates the cost at any particular time. if we now go and replace t with 8, which is what the question tells us to do, we're going to find the cost is going to be approximately $8.23. Of course, you would then give your answer in an appropriate way. You would then go and say something along the lines of, therefore, cost after 8 years will be, and that's what you'll do to answer the question. So you must always make some sort of statement about the variables that you're using and what the units are. Your initial starting equation, fill in your initial amount, fill in your growth factor. Just be aware, with growth factor, the growth factor can be greater than 1, in other words 100% plus something, or growth factor can be less than 1, 100% minus something. So if something's decaying and you have 100% and every year you're losing 3%, 97%, so 0.97 would be your growth factor in that case. So start by stating your variables and the units, a generalized formula to start with, which you fill in the values that you're given, and then give the answer in some sort of appropriate sentence. And that is growth and decay. I'll put one more, next video, we'll do exactly the same question, and we'll do it to do with compound interest and money.